Hey guys, hope you're all doing okay. Welcome to the complete tutorial for RPCS3. In this video, you're gonna find everything that you need to know about RPCS3. How to set up the emulator, what do all the options mean. This is going to be a detailed video, so I'm gonna put timestamps in the description. But I do recommend watching the whole video. Let's get started. To give you some perspective, these are the minimum specifications, and let's call it low end, and these are the recommended specifications. Let's call them mid end. Anything above that is high end as always. I've been closely monitoring RPCS3 build since 2011. I remember when I first downloaded the pre-alpha release, a proof of concept which it was. It was just a teeny tiny window with only one drop down option in the UI. It was just an interpreter debugger. It was only able to run a tiny part of the PS3 firmware code. Very comforting to see that after 15 years of console being out, we can play several titles on the emulator. My and community's undying gratitude towards RPCS3 developer team and Patreons. PS3 architecture is extremely tricky. So many rendering pipelines, modules, and the way they communicate with each other, the PPU, the SPU, and shaders, all very sophisticated. It was a relatively hard platform to develop titles on, but also had a lot of untapped potential. Developers slowly got the hang of it, and we were granted games with relatively amazing graphics and smooth FPS. Small problem, however. This kind of design is ridiculously difficult to emulate because a PC consists of CPU, RAM, storage, graphics, along with different data lines and buses in the motherboard. Tricking each part into doing what PS3 does is the main game here. So that's your answer to the question, why does my PC require so much specification when it is 50 times more powerful than a PS3? As the making of this video, more than 1900 titles out of 3100 are playable from start to finish. This goes to show you that team put a lot of effort into making of this emulator. Okay, so as you know, there are two ways to download this emulator, mainstream release and the GitHub revision. So in this instance, we're gonna go with the mainstream release. So you can just go to rpcs3.net. So this is their official website, and just go to the download section to download the latest revision. So here's our version for Windows, and here our version for Linux. We're just gonna download the version for Windows. If you have Linux installed, you can download that, I guess, but the intricacies associated with Linux, oh my god, I don't know how would you solve an issue regarding this emulator. So I hope that you have Windows. I've already downloaded it, so I'm not gonna download it again, but hopefully that was helpful. Now you need to have Visual C++ 2019 installed. I've put a link in the description if you guys want to download the standalone version. Remember to restart your computer after installation. The final thing that you need is the PlayStation 3 firmware itself. Again, link is in the description, but you can also download it at the PlayStation's official website. Last thing, we need RAP files, RAP files to boot PS3 games. RAP files are used to activate PS3 games. These can tell the console whether a game is pirated, copied, or ripped. Only original games came with their own unique RAP files, which are used to tell console that the game is legit and original. You can Google each game's RAP file and download it, find it on websites like PSNDL by using its name and region like PAL, US, JAP. Otherwise, the games won't boot on the emulator. I don't recommend you do this because the only legal way to play PS3 games on the PS3 emulator is to extract your own from the PS3 disc that you already own or buy some legit disc. Sorry guys, trying to put a disclaimer as I want to be as thorough and clear as possible. Thank you for understanding. Ideally, try to install it in an SSD if you have the option. It will help with the compilation times. If you don't have then an SSD, that's fine too. So let's see here. It's in this directory RPCS3, and this is the PS3 firmware file. I've already downloaded it, and this is our downloaded version for RPCS3. I'm just gonna extract it here. Yep, it's extracted, and now I'm gonna launch it. So it says RPCS3 does not condone piracy. you should dump your own games. So I've read the quick start guide and don't show me again, continue. So now we're at the main UI. There's something I would like to mention. I was running this emulator on a really crappy laptop. It's a very old machine because I like to see how far I can push the old hardware. I got a Vulkan API error. If you get that too, I have a Vulkan API installer in the description that you can download and fix that error. After everything is set up, it should launch without any hindrances or errors. Okay, so let's get started. In File UI, we have boot self ELF. ELF is the PlayStation 3 boot file extension. PS2 console had the same extension. If you want to boot just the boot file of the game or a PS3 software for debugging purposes, you can boot that file. For example, if you're using Codebreaker or Action Replay or some sort of trainer or cheat system, you can use this option. And boot game is gonna let us boot our game. Now there are two types of games. One is extracted, which is going to be a directory or a folder, and the other one is PKG or package file, which you have to install. And normally our default game directory is dev hdd0. This is our main game directory where our game is going to be stored ideally, but you can also give it a custom path, so it's not a problem. Now, next up we have install package and wrap files. You can install package or associate different types of wrap files with the games that you already have. Then we have install firmware. Now we're gonna install our firmware, which we have it right here. So let's install it here. It says old firmware detected, the newest version is 4.87 and you're trying to install 4.86, continue installation. Actually, I downloaded this a while back, so I'm not gonna bother with the new version, but you can install the new version if you have to. That totally up to you. So I press no and hopefully should start the installation. Okay, I said I think it's a continue installation. I press no, so let's press yes. So you might be asking, what's the difference between the two firmware versions? So they like to revise the firmware because sometimes you can find undiagnosed bugs which were completely unknown before, but they just fixed it. But in the emulator, from an emulator perspective, it doesn't matter that much. But if you want the ultimate performance, you can download the latest revision of the firmware. That's totally up to you. But I already had the previous version, so I didn't really bother. Okay, so let's go through the other options. Then we have all titles, and here we have create PPU caches. So after this is installed, it can now run PS3 games. It's going to compile the PPU module, which are required models that come with the firmware, so it can let us emulate the architecture. So you see this running in the background, so that's what it's doing. And in all titles we have PPU caches. Whenever you run a title, it's gonna compile its own SPU, PPU and shaders. So these are your CPU, GPU and shaders. This is done to let emulator access the game files. By having these on standby, it can reduce loading times, recall graphic shaders, and link the SPU with our unit. In short, instead of loading shaders, linking PPUs and SPUs every time you boot a title, you can keep these files on your SSD or hard drive to eliminate the compilation times. Depending on the game, the more you play it, the bigger is gonna be your shader bank. So from here you can manage all those options. Yeah. So in firmware we have create firmware cache, remove firmware cache, any additional or system files that firmware might create, we can manage it from here. Next up we have emulation, which is pretty self-explanatory. Pause, stop, restart, open command prompts and exit command prompt, which is gonna let you view the logs or open the command prompt for any reason that you like. So whenever you play the game, the more you play it, the smoother it's gonna feel, relatively smoother. And one of the amazing RPCS3's function is that it lets you create custom configuration files for each of your games. Different controllers, different renderers, different settings, a whole lot more. So depending on the game, because every game is going to support different settings, and you can string a bunch of different settings together to see which ones work for your game the best. And that's how you can get the best performance out of a game. Okay, so except for pads, this one, and RPCN, this one, you can click at any of these options, or you can click here, and it's gonna take you to the same generalized, centralized settings area. And now we're gonna go through these emulation settings before jumping into pads or the network settings. Okay, so here we have our PPU decoder and our SPU decoder. We have two options, interpreter and recompiler. Recompiler is the fastest option, so just select that, because interpreter just translates the code line by line, while recompiler takes the whole code, translates it, and executes it, so it's much faster. But interpreter is way more useful to track bugs. So if you want to track bugs yourself in a game or in the emulator, you're always gonna select interpreter precise. So that way you can track bugs. But I don't think that anyone is gonna be tracking bugs, because it's a very time-consuming process. Here we have recompiler ASMJIT. This is the old recompiler, and it works with the low end of the spectrum. You can select this for a couple of your games, but this one has excellent implementation, so most of the times you're going to be using that. But if you get any runtime errors because of the games, you can just fall back on this recompiler. But I don't think that you're going to be using this one, because LLVM has excellent implementation nowadays. They really stepped up their game in the latest revisions. Okay, so next up in additional settings, we have enable thread scheduler. Whatever operating system you're using, especially Windows, it's going to have its own scheduling priority. So that means that Windows is going to tell the processor and the system how it should prioritize tasks. Which of the tasks is going to get most of the RAM, most of the CPU, most of the GPU, and stuff like that, something along those lines, yeah? But we are going to override that settings with our emulator settings, enable thread scheduler. So our emulator is going to tell the resources that how they should be allocated. So definitely enable this option whether you're on a high end or low end or mid end. Lower SPU thread priority is particularly useful on low end of the spectrum. So if you have a low end PC, try enabling that, especially if you have 2 cores. So if you have a dual core old processor, try enabling that. But in my experience, it's a very experimental feature. I didn't get that much performance gain, so I just leave it disabled. But depending on the game and depending on the circumstances, you can try enabling that. So if you get better performance, then leave it enabled, otherwise leave it disabled as default. Enable SPU loop detection. This is a really useful feature, and you should always leave it enabled whether you're on a high end or low end, because it detects if there's a loop. So instead of just executing the same instruction over and over and over again, it can just detect that there's a loop coming, and then it can just run the loop and you can get potential performance. Yeah. SPU cache is like a CPU cache, where instead of just fetching the instructions over and over again, you can just fetch it from the cache, because it's way faster. So enable that whether you're on high end or low end, and it will ensure your stability and your performance. Accurate exfloat is a feature in RPCS3 where you can fix some bugs, but it's going to cost you a lot of your performance. Some of the bugs can be fixed by checking this option, but I must warn you that you're going to get 12 to 15 to 17 FPS or something like that. You're going to get amazing accuracy, but you're going to get like way less performance with this one. But it kind of fix bugs. So there were some games where I was stuck in some areas and game would just crash, or there were some horrendous bugs. So I just enabled this option, got through those areas, at a low speed, low FPS, and then I disabled it. But you should leave it disabled because I don't think that gaining accuracy is worth sacrificing as FPS. TSX instructions should always be enabled. So this is the instruction set, like for PS2 we have SSE, SSE2, SS3, SSE3, SSE 4.1, AVX, AVX2. So these are the CPU power tools that tells that lets CPU perform some very complicated calculations. So SPU block size, so it's the data block size. How big do you want it to be, mega or giga? If you have a big SSD or a big hard drive, it's worth trying giga or mega. In my experience, I didn't notice any performance gain, but it was actually counterintuitive where I got some stuttering, so I don't recommend using it. Just leave it to safe. Again, it's an experimental feature, so try with your different games. Preferred SPU threads is auto, let it decide, so don't worry about that. In GPU section, we have renderer and I've select Vulkan, so it's going to be selected by default. Now remember, Vulkan is the fastest renderer while OpenGL is the most accurate renderer. So we have selected here Vulkan, and in the latest revision they've really implemented Vulkan compatibility in the emulator. So for most of your games this option is going to work just fine. However, if you get some graphic error or slow speeds, you can always select OpenGL, which is more accurate. But if you want the best performance, select Vulkan. Now I must warn you that you're not going to have Vulkan option if you're using a low-end PC. So just keep that in mind, because on low-end PC it's not really supported. So you're only going to get disabled video output and OpenGL. So just keep that in mind, and you're just going to have to go with OpenGL. It's a relatively new machine. It's a 6th generation i7, not that high end. It's actually a mid-end to low-end, but it does have Vulkan. So select Vulkan if you have. Here you can select the graphics device is selected, aspect ratio, frame limit, anti-scope refiltering, anti-aliasing. Default resolution is 720p. We can select 1080p, but this is the best implementation. Just leave it to that, leave it to 720p. If you have a high-end PC, you can, and by high-end I mean high-end graphics card, you can select full HD, or if you want to go crazy, then just use this slider and it will let you do the resolution scaling for yourself. Yeah, but in my experience 720p is the best, even if you have a low-end PC. Even then, if you drop back to 480p on a low-end PC, it's going to give you worse performance. So just select 720p. But again, if you want to experiment for different games, you can just always select 480 on a low-end PC and full HD on a high-end PC. But this is the sweet spot, the best compatibility. And if you do choose to use this slider and choose your own crazy resolutions, you might get some weird artifacts or missing graphics, and then you can use this scale, resolution scale threshold, and it might solve some of those problems. In the latest revisions, I think it has a good implementation, but again, these are experimental. Legacy single-threaded in the shader mode, it's an old way of doing things. It's going to be really slow because it's only using single-threaded, but it has way better compatibility. But I don't think that we need to worry about that because most of the machines out there are multi-threaded and multi-cores, so we can just select async multi-threaded, and in the latest revisions it has a really good implementation. Async with shader interpreter, as I mentioned before, interpreter is a really slow method of translating the computer code into assembly code and then running it. So do not enable any of these options because we're just going to keep it to that. Okay, so number of shader compiler threads, we're going to keep it to auto, let it decide. Write color buffers. So our color buffers contain our RGB and sRGB color data. So this data can be used for various purposes. So if you want to enable that, it's experimental. So just use it as on each each of the games that you might have and that you want to get the best performance out of them, but don't use it as a global setting. In strict rendering mode, the second option, sometimes you can get an error because of the API. So for example, if you have a Vulkan error or OpenGL error, you're playing a game and then you get this error regarding an API, you can select this and it will bypass the API compliance. So it will basically let you run run the game even if you don't necessarily meet the criteria for the Vulkan render or the OpenGL render. VSync is the option where it's gonna let you prevent screen tearing effects. So, but it can take a toll on your performance, so don't enable that and never enable VSync. Stretch display area, if you don't want the black bars up, down, left, right, so just stretch it, you can do that. So in some of the games there's a 3D option, so enable 3D view or enable 3D, you can use that, but I don't think it has that much practicality, and it's still the emulator is still in alpha phase, so I never enable that, but you can try if you want to. Disable vertex cache, it's never a good idea to disable the vertex cache, never disable that, because it's gonna let you store all of the GPU's most used data. So if you're just fetching the data from GPU over and over again, when you need to fetch data over and over again, you can store it in the vertex cache, and instead of fetching the data from GPU, you fetch it from vertex cache. Don't disable it unless you have a high-end GPU. So if you have RTX 3080 or something crazy like that, then you can disable it, because then it would make sense, because your graphics card is actually faster than the cache because of the newest GDDR6X memory. So multi-threaded RSX is also a very good option. It stands for Reality Synthesizer. Reality Synthesizer is the GPU for PlayStation 3, which was co-developed by NVIDIA and Sony. And if you have 4 or more cores, definitely enable this. It's worth a shot. So 4 or more cores, high-end PC, definitely enable this and try it with each of your games. I can't stress that enough, that the best thing that you can do with an emulator is try different settings together. Okay, so in audio section we have XA Audio 2, which is pretty self-explanatory. I'm not gonna explain all of that. OpenAL is also another plugin, but I think XA Audio 2 has the best implementation. If you want 5 to 7 FPS increase in some scenarios, in some specific scenarios, and you have a low-end PC, just disable audio output. So if you disable audio output, in some cases it can actually give you more FPS. So just throwing that out there if you have a really crappy PC, low-end PC like mine. And audio channels down mix to stereo again has the best implementation, that's why it's selected by default, or you can use any of these profile. I think they have pretty good implementation as well. If you want all of the audio to be dumped into a file, you can select this option, or convert to 16-bit instead of 32-bit. Here you can select the microphone, but I don't have any microphone attached, any of the external microphone. I have the volume, enable buffering. I just disabled it, so that's why it's not letting me enable that. Yep, enable buffering, always enable buffering, because it's gonna let you process the sound. In I/O, if you have the joysticks or the steering wheels or the pedals or any camera or sensor, motion sensors, you can just select from here, but it's still in alpha phase, so I don't recommend that you do any of that. Just play with your keyboard or your controller. Again, you can try, up to you. In system you have English keyboard, pretty standard stuff. Clear cache automatically. I never clear cache because then I'm gonna have really crappy compilation times, so never clear cache. Unless you want to install a newer firmware version, then you can clear cache. But if you're just sticking to the old firmware, that's fine. In network settings, we have network status, which is disconnected, PSN status. So simulator RPCS. RPCN actually lets you connect to a customized server if you want. But again, don't mess with these options because they haven't been implemented yet. And in advanced, we have debug console mode. So remember when you wanted to tinker with your firmware, if you want to do that, just do debug console mode. So it will let you emulate that function. And here we have accurate LLVM DFMA, and I think it's, let me see, it's only compatible with OpenGL, I think. It's not enabling it for some reason, but it's actually just a flag for your compiler that it's going to give you better accuracy. It's already enabled. Accurate RSX reservation access. So if you've enabled this option, try stringing that option and this option together to get the best performance gain. But if you were getting low FPS, then just disable this one, because it's more for accuracy and not for performance. PPU LLVM accurate vector nans. I think this one works best if you yeah, it's gonna work best with the recompiler. So to string this setting, you're gonna have to select OpenGL, go to advanced, and then select it. So this is the best combination of settings. But if you have Vulkan, then don't enable that. It's gonna give you more of an accurate emulation. So silence all logs. If you don't want anything to do with logs, you can use that. Sleep timers accuracy is pretty self-explanatory. Remember when your PS3 console just went to sleep and put the screensaver on. So I think it's emulating that. Sparse threads are unlimited. The firmware libraries are some of the specific options that you can enable to get the most out of your emulation. So if you want a specific function which is not available by default, so I can just select one of them and then get that option. But they're mostly for debugging purposes, because look at how many there are. So if you want to track down bugs, you can just use these libraries. Read and write depth buffers. It's worth trying. Read depth buffers and read color buffers. Again, these three are experimental features. Sometimes they can increase performance, but in Dark Souls, I think you get a black screen. But definitely try these options on each of your games if you want to get the best FPS. These contain RGB and sRGB data. So, and these are experimental features, so try that. Try stringing them together and see if it works. Disable on disk shader cache. Never check this option, because you're not going to get on disk shader, so you're going to have real-time shader compilation. So what's the purpose of disabling this? Because you're already going to have so many shader files on your disk, and you need to use that. So if you disable that, you're not going to use the on disk shader file that you've collected for God knows how long. Disable native float 16 support. This can actually give you a little bit less accurate performance, but sometimes in some of the games and some of the code, it can actually give you better performance but less accuracy. Okay, so in relaxed Z equals sync, I think this is our last option in terms of performance. So Z culling is a technique where you do not render the unnecessary objects. For example, let's say I'm playing a game and there's a house nearby. Let's say I'm playing Red Dead Redemption 2 and there's a house or there's a bar, but there are also objects that are behind the bar. But I haven't gotten to that area yet, so it would be pointless to render those. Yeah, so we're not going to render it, and it's going to give us a little bit of performance. But if we have a high-end graphics card, then why won't we want the accuracy? Why won't we want the smoothness? So if you have a RTX 30 series graphics card, you can leave it enabled. And in emulator, we have pretty much the standard stuff. We're gonna leave it here. This is gonna let you see the FPS on your top left corner or wherever you want. You can select it from here. And in GUI, you can use any of this, customize your UI. Yeah, so like that. Totally up to you. Pretty good, I would say. And then we have pads in here. If you want to attach a controller, you can do that through here. Xbox controller, DualShock, or any of the custom joysticks that you might have. You can adjust the sensitivity here. But if you select DualShock 3, it's gonna let you adjust all of that good stuff. I don't have it connected, so that's why it's not letting me. Or you can make a whole new profile and choose a profile whenever you're playing a game. So custom controller. So it's a pretty standard stuff. And advanced, I think we already did that. We have RPCN. So if you want to connect to a customized network, you can do that through here. The host and then the username and password. And if you have set up a token system, you can put the token in here. Totally up to you. But again, it's in alpha phase, so it doesn't have the best implementation. So if you're planning to just play multiplayer, then I wouldn't recommend that. In trophies, we have Skylanders portal. It's a game where you can use this portal for the game. Here you can adjust the make sure that your games are in a grid or they're in a list, and here you can zoom in, zoom out on your games. Then we have show debugger. We don't want anything to do with the debugger. I don't know how to debug this emulator. Game refresh, and then these are the pretty simple tools. Decrypt PS3 binary. So some of the binaries that you might have might be encrypted. I had like a couple of encrypted binaries. I tried to decrypt them through this option. It didn't really let me. Always gave me an error, but you might have better luck than me. Okay. So there we have it, guys. That's our complete look into RPCS3. Hopefully I covered all of these options in detail. Now I'm gonna do the low-end settings. So if you have a low-end PC, follow these instructions. Recompiler, yep. Experimental, so try enabling, disabling that. Enable safe auto. GPU Vulkan. Perfect, default, async. Perfect, same. These are also experimental, so make sure that you try it first. and for high end I always do these settings. Okay, so that brings us to the end of the tutorial. Hopefully I've covered everything, and hopefully this video was helpful to you guys. I think that's it. Yeah, thank you so much for watching. Catch you guys later.